Hey everyone, day 14 today. We're heading into Friday to Saturday, so again, expect this to be relatively difficult. It also means that day 21 or so will likely be the most difficult time. Just looking at how the weekends pan out. Okay, so this data we probably want to split by row and then no grid. Cool. We have positions, we have velocities, and x and y. Okay, so maybe there is a grid after all. They're good at navigating above and below. Okay, cool. So the robots outside are in a space of 101 and 103. Okay, cool. They can teleport. Teleport to the other side. Okay, what does teleporting to the other side mean? So in this case, it goes up there. Oh, and then it just went through. Sure. Okay, where will the robots be after 100 seconds? Count the number of robots in each quadrant. Oh, okay, yeah, cool. So that's not bad. So basically we want, so we want to build a robot. Let's just have a class called robot. We have int x, int y, int vx, int vy to represent position and velocity. This could be a record class, but I might end up needing to do more with it, so I'm going to actually do the full class, even though it's slightly slower than just using a record. It's not really that much slower than a record anyway. Okay, cool. So now I need to figure out how to parse it, right? Which shouldn't be too bad. We really only care about 4 values here. So we can parse on the space, right? So this one will get us position on one side, velocity on the other. So we can parse on equal sign and comma for each. So we can do, what is this? Let's just have a list of robots. Right, so we can get rid of this, get rid of this. Cool. So then we have, how do we split from here? Okay, actually, let's just split on space, comma, and equal sign. So space or comma or equal sign. Then what we can do is quickly print out this just to see which ones we care about. Cool, so we care about the 1 index, 2 index, 4, and 5. 1, 2, 4, 5. So we want to do robots.add new robot, integer.parseInt parts 1. Right, so that's one of them. So we said 1, 2, 4, 5. 1, 2, 4, and 5. Cool. So now we have a bunch of robots, and for part 1 we can do counter equals 100, and we want to simulate each robot after that time. Cool. So while I like using this notation solely because of the fact it kind of looks like an arrow, so it reminds me of how this works. Counter minus minus, and then we want to do for each robot, we do robot.x plus equals robot.vx, robot.y plus equals robot.vy, right? Okay, cool. So we have number from the left wall and number from the top. Okay, and the height is slightly different. So the height is on it, so y goes 103. Cool. So now we're done, right? And then, so we have 4 quadrants, right? So int quadrants equals new int. So we start every quadrant at 0. Oops. Cool, and then for each robot, we assign them to a given quadrant. So if robot.x is greater than, what is it, 51, the other case is, of course, robot.x less than 51. 51 is the dead center, so we don't care about it. If robot.y greater than, what was it, 103, so 52. And of course we want robot.y less than 52. And what happens? We just get the number of quadrants and then count them all and then multiply them together. Cool. We'll do, this one can represent the first quadrant, doesn't really matter. This one can be, second, third, fourth. Cool, and then we just do answer equals quadrants 0 times quadrants 1 times quadrant. This has made me realize that I might actually need to make this a long. Let's just make this one a long. That should make the entire multiplication a long. New int array. Oops, did not mean to put that in. Okay, that's a number. We'll try it out. And then it's not right. We will try the simpler output. Oh, of course it's not right. I need to do mod 101, mod 103. Actually, let's do this. Int x limit 101 and y limit equals 103. X limit. That way we have something changeable. Cool, so that's a different value. It's bigger, which makes sense. I'll put this in for now. But then also, let's try out the example to see if it would return the correct thing. So this example returns 0. Ah, lovely. Oh, right, because so let's actually do, so what is this? X limit plus 1 divided by 2. And this is y limit plus 1 divided by 2. Cool. So if we set it to 7 and 11, right? That's what the thing is. 7, 11. Oh, everything is still 0. That doesn't make much sense. Maybe we can do a quick little public string to string action. Right. And then let's just print each robot. Oh, those are definitely robots. Oh, I see, because some of them are negative. That's a concern, I suppose? I'm still surprised the quadrants... Oh, yeah, probably none of them ended up in a specific quadrant. That's fine. Okay. So we actually want to do something slightly different here. We can just do robot.update, right? And then we can sort of build in a public void update. So do vx plus equals x vy plus equals y. And then we want to do actually x limit, y limit. Oh my goodness, this is a remarkably easy part 1 though. I'm sure many people are done here. I'm just kind of struggling a little bit, which is fine. So x equals x mod x limit, x plus equals x limit, x equals x mod x limit. This is the long form way of doing it, but I think it makes it very obvious what I'm going to do. I'm trying to get the positive version of the residue, basically, rather than just any option. Cool, okay, now let's look at it. It should all be relatively reasonable values. It is, and that answer is correct. So let's just flip it back to this one. Set the, what did I click here? Okay, set the x limit to 101, set this to 103, run it again, get a different number, hope that's right. Ooh, that is not right. That's unfortunate. Why is that one not right? Huh, that's a bit surprising to me. Teleporting, which is reasonable, a number in each quadrant. Is that, okay, maybe I should have just printed. Okay, back to here. Let's make sure they're actually the right spots. 7, 11. Right, those were the limits, right? Oh, it was 11, 7. Oops. And the other one is 101 wide. Positive x moving, right. So this is actually wrong. It should have been 11, 7, right? Oh, but that gives a different answer. That's not good. Why would that be the case? Huh. Okay. Very odd, very odd. Let's go look at the final state. We have 1 at 0, 0. Well, that's quite bad given there's nothing at 0, 0. Is this greater than or equal to 0? I don't think it is, right? There's still something at 0, 0. How are you possibly always, and there are now multiple things at 0, 0. No, that's not right. Okay, let's just look at, yeah, let's look at one of them. Let's trace one of them. So it goes, okay, so we're basically counting from the bottom left point. Oh, 2, 4. Oh, no, we're counting from the top left point. Sure, that's quite reasonable. So 2, 4 becomes, what is this, 4, 1? Is that right? 2, 4 becomes 4, 1. 4, 1 then phases through and becomes 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6, 5. Cool. So that actually looks quite right. So I'm pretty sure this is greater than 0. 3, 1. Is there anything at 3, 1? 0, 1, 2, 3, 1. Nope, there is absolutely nothing there. What in the world? Okay, well let's do greater than or equal to 0. See where it ends up there. Actually, wait. Okay, where does it end up after, say, after one cycle, right? 4, 1. Oh, okay, so it is greater than or equal to. Cool, okay. So greater than or equal to, let's go to 100. And its coordinate is 5, 5. Is there anything at 5, 5? 0. No, wait, right? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Yeah, there's nothing there. Is this a real coordinate? Like, is this one of them? Yeah, it is one of them, which is real bad, huh? Right just into the edge of the space. What is going on? Okay, like if this is 0, right, then I'll trigger once. Oh, wait, what is... Oh, there's multiple prints. No. So we do want greater than, right? Yeah. Okay, so now if counter equals 1... Oh, this line is baiting me. Okay. But this is the line that matters, right? Actually, we do care about... We only really care about the ending position. So... Oh, because this is... Right, so it ends at 4, 1. Yeah. This is good. So 2... Again, this is where it is, right? It ends at 4, 1 again. Huh? Wait, what? Okay, what about 3? It ends at 6, 5. No. So it is with the equal sign then. How is it possible that it gets the same value for the two? What is going on? Greater than equal to and greater than should be very different concepts. Like strictly different concepts. Okay, well they're obviously not. Oh, because I'm doing it in a separate minus. Oh my goodness. That is quite the blunder. Okay, so after 3 seconds, it is at 8, 2. Okay. So now at 100 seconds, it's at 4, 5, which is one of them. Yippee. Oh, sorry, that's 5, 4. But yeah, it is also still one of them. Okay. So now, we get 0. That's not it. What? How do we get 0? So we have 3, 5. Yeah, I see the 3, 5. 5, 4. Yep, see that. 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. 9, 0. 4, 5. Yep. 1, 6. Oh, that's weird. There's no 1, 6. Am I looking at this wrong? Like, what if you're 7 and you're 11? Am I misunderstanding the limits here? Nope, that's not it. Okay, cool. Why would this not be right? We have something at 0, 2. Oh, okay, yeah, 0, 2. But there's nothing at... Oh, wait, 6, 0 is here. Okay, wait, 6, 0 is good. Oh, I see the issue here. No, this is too big, right? Because the indexes start at 0. So I'm actually cutting the wrong cross section with this. Okay, let's remove 1 from everything. There we go. That's the correct cross section. Okay, now let's go back here. Go to 101 and 103. Nice. Okay, that was not great. They're the same type of robot. They have a hard-coded Easter egg. They should arrange themselves into a picture of a Christmas tree. Oh, that is quite something. Okay, so we do need a grid now. Cool. So we can put this in the else section. All right, so Christmas tree is interesting. We'll do 100 and then let's do a grid, right? Int grid equals new 101, 103, and then we can make a grid. Each stage we first clear the grid. Actually, rather than doing that, we just do this. And for each robot, we can let it update, and then grid robot.x, robot.y equals 1. Then at the end, we can do for row in grid, we print it. All right, and then we should start the counter at 0 now and do something like that instead. Oh boy, this is going to be very hard to tell if it's a Christmas tree now, won't it? Alright, let's design a pretty print. Take in a grid. And then maybe we do something like this. I could have done robot instead of item, but that's fine. How does this look? A little better. Let's do maybe a blank space versus a pound symbol. That looks kind of filled. Okay. Do any of these vaguely resemble a Christmas tree to you? Absolutely no idea. Okay. What would you expect a Christmas tree to have? Maybe a lot of elements that are in diagonals with one another, so like with slope 1. I don't know how to spell diagonal. That's kind of awkward. Let's do a list of robots. I don't know, maybe this is kind of dumb, but my basic idea is literally just have like for a robot and robots, for a robot and robots. Right, like if robot if math.abs robot1.x minus robot2.x equal math.abs robot.y minus robot2.y, answer plus plus. And then we just return. So if there's like a lot of diagonals, because like I feel like Christmas trees would surely come with many diagonal elements. So if we do just system.out.println diagonal robots, like let's see roughly what values we're working with, right? 3,600, 3,800. Okay, so what if we do like diagonal if diagonal robots greater than 3,800 preprint grid. Yeah, I don't know. How about then if actually make this a little stretch, because I feel like if it's 1, then we actually probably want to even incentivize it more. Something like that. Now what are the values? Alright, I should remove this for now. No. Perfect. Removed the wrong element. Now we get up to 4,000. Yeah, okay, let's do 4,100. What's going on? Oh, I see. Sure. Like, is anything above 4,100? Oh, there's a lot of things. Whoa. Yeah, I guess it incentivizes a lot of close together elements. Still nothing that looks remotely like a Christmas tree, though. Unfortunate. I'm hoping I recognize a Christmas tree when I see it, because there's a chance I don't. Okay, what about 4.2K? So let's only print this if I'm actually doing this. Yeah, I don't know. Still nothing that looks all that much like a Christmas tree. 4.8K. Some very high numbers. Alright, let's bump this up to 4.9K. Thing is also, like, I have no idea how high up to go. Okay, another thing I could do is, I feel like there's not going to be that many duplicates. So let's remove duplicates. I never trigger a single time. That's quite unfortunate. Okay, 4.5K. Oop. 4.1K. Okay, so still get some at 4.1K. Nothing that really looks like a Christmas tree. The other thing is, I'm not confident I'd actually know a Christmas tree by looking at it. Right? Like, I don't know, man. I'm not a big Christmassy guy. Yeah, these really do not seem to be it. Well, there's probably a base to the Christmas tree, which suggests that if they're the same... Oh, I'm also probably looking at it sideways, actually, now that I think about it. Right, let's do... Wait, the width is 101? So what happens if we look at it more like this? Still nothing that really catches my eye. Yeah. Not the most Christmassy looking of things, for sure. Okay. Well then. What else can we consider? There's probably a base. I feel like there's a good chance there's a base. So... in that case, we want to prioritize things that have higher values of x while having different y's. Oh no, I made things too easy. Okay, let's try 6,000. That's still a lot. 6.5 thousand? Wow, even that's a lot. How big do the numbers get? I don't know. Let's try 7.5 thousand. There's still a lot. This is crazy. Oh my goodness, the values get to 12,000. Alright, let's go to 15,000. Oh, nope. Nothing at 15,000. Okay. We should also probably remove that stupid print here, given we know part 1 works. 14,000? What if we increase the count? Oh, that looks very promising, doesn't it? Let's try this number. Nice. Wow, okay, well, the tree really did look like the tree. And these, yes, I knew it had a suspicion of a lot of diagonals, a lot of these lines. It was actually very important to get my x and y straight. That is one big thing to know, is that, like, make sure you keep track of how you want to display it, because this one displayed sideways obviously would have still looked like a Christmas tree, but like if it had been any less obvious, I think you clearly would have wanted something like this. Honestly, in this case, we probably could have done the other thing as well. Okay, 14K seemed pretty alright though. It's the only result. Yeah, I mean, I don't think there's like a super obvious way to hard code this, just because, it's going to depend a lot on what you consider Christmas like. Um, Much more subjective. So I suspect my code won't work for every day, but, and sorry, not every day, like not even everyone's input necessarily. Uh, but, I think it still is reasonable. As sad as it is, I do think I need to get rid of the pretty printing, just because when I run all 25 days for stuff like timing, the Christmas tree is nice, it's pretty, but I probably don't want it for that. So, sorry. I do like what I chose though. The tree looks really nice with these spaces and hashes. I like hashes because they're mostly white and spaces are obviously completely black, so it provides good contrast. Obviously, many possible options for sure. Um, Pick your favorite. I would say if you're planning on doing this problem, settle on something that's easy on the eyes. Again, doesn't have to be spaces and hashes specifically. Also, if you're in light mode, I'm sure this looks completely different. But yeah, pick something that you feel comfortable with. Sorry, I'm just cleaning up right now, seeing how everything looks. This is also really slow. I should probably figure out how to optimize my method in general. I mean, this is what, I don't know how many robots this is. Let me see. Yeah, 500 robots updating over thousands of times. Oof, not the greatest for sure. I could simplify this at least. Maybe just make it a single thing. Let's see. I don't even know if this is faster though. I mean, it's cleaner looking, but hard to say. I mean, surely the compiler just optimizes away these details, right? Like, but let's see. Maybe this is faster. Maybe it's wrong. Okay, it's the exact same speed. So be it. I don't need toString anymore. Is there anything else to consider here? Yeah, this is very janky. But I kind of like it. I think it's makes sense to reward things that close together, makes sense to reward diagonals. Cool. Okay, now I do want to show off one more thing. I actually did get AOC tiles working, and by me, I mean the owner of the repo for AOC tiles actually graciously helps me out a lot. So I do want to show that off a little bit. So if you're still here, thanks for staying all the way. But also, let me just show you how a lot of my tiling works. So, sorry, just adding the days in. It's very nice actually. It just triggers automatically on commit. It's a pre-commit hook. So if I do day 14, commit, you see detects some files, adds in some stuff, and then if I push it, let's go to my GitHub. See, right now it looks like this, right? You see there's 13 tiles. Well, that's awkward. There's no 14th tile. Oh, I have to add it, right? Oh, I'm really not doing a good demo here now, am I? I apologize, whoever this is for. I swear, this is a very cool tool. If only I actually used it properly. Why am I so good at forgetting to add the word add? Okay, take two. Cool. Let's see if this does it. Boom, yeah, a new day, which tells me my ranking. So I can actually see every day's ranking in this very nice graphical way. Let me actually see if I can find on GitHub. Yeah, here. So this is the repo if you're interested. He has an even prettier setup because he's optimized a lot of his stuff. There's a ton of settings, ton of options you can choose for individualization. So yeah, if you also do AIOC problems, would recommend setting this up on your repo. Make it a little prettier. With that though, I will see you tomorrow.